So what we're going to start is graphing systems. A system is more than one equation. So you don't just have one line now, you're going to have two lines. And so when you solve it, the solution is the intersection. So when I say intersection, what do I mean? That's the point where they do what? They're the point where they meet. So it's actually very simple. This is one of the easier units. Yeah, your desk got tilted, not yelling at you, it's not your fault, but you don't need to rotate so the tracks need to rotate. So look, I'm gonna go through the options here. Do you see these two lines? How many places do they intersect? How many times? Once. Do you see how one right there? One solution. Do you see that? How many times do these lines intersect? No, here, actually, let's write this down. This is one solution. This is no solutions. You could say no solutions. I wrote zero solutions there. Now, this third one, it looks like only one line, but what's happening is you have two lines and they are exactly on top of each other. Do you get what I'm saying? So they intersect literally everywhere. And so that is infinite solutions. Very good job. So it looks like only one line, but it's actually two lines where one is on top of the other. Oh, whoops, I just ended the wrong pass. Oh, well, life goes on. Chris, I'll put in your pass for you. If you just hold on a second. You're welcome. All right, be quick. All right, so you can have one solution, zero solutions, or infinite solutions. Follow-up question. Could you have lines that intersect twice? Could you get two solutions? Because it's not going to go blah, blah, blah. It's not going to turn around. Do you see what I'm saying? This line, can you guys be quiet and listen to me? Do you see how this line's going to go forever this way and forever that way, and these will go forever each way? They're never going to be able to intersect a second time. Go ahead. So there's not, I guess I should have been more specific. Can you get specifically only two solutions? No, you can have one, zero, or infinite. All right, so verify, that means check if it's true or not, that the points below are solutions for the system of equations. Is 2, -3 a solution? This is super easy. Can you guys just watch? I'm going to go to the Desmos and type in that first equation, 2x minus y equals 7. You see how I did that there? Line showed up. What's the other one? 5x plus 1/3 y equals 9. Do you see how I just typed it exactly like it looks? Now my axes are a little bit messed up. Do you know how to turn it back to normal? What button do you hit? Home. Okay. So what I'm going to do is click on the intersection. Do you see it right there? Boom. What's the answer? 2, -3. So let's go back to the paper. Is 2, -3 a solution? Easy peasy. You just have to be able to use your calculator. All right, let me share again. We're going to try the next one. I'm just going to go and type that in. 3x minus 4y equals 4. And then, oops. I know it's not super fun to watch me type stuff, but what I need for you to do is verify I'm typing it correctly. Like if I mess up, you guys get to yell at me and be like, hey, Miss Cole, you messed it up, you know? All right, minus 4y equals 6. The cool thing about this is the calculator does it for you. Got to look up here. Here now. All right. But if you type even one thing wrong, it's going to be wrong. So you got to be careful. All right. So I'm going to click on the intersection here. I'll zoom in. Do you see this intersection there? Oh, I typed it wrong? Oh, whoops. Oh, thank you. And that's what I was just saying. Thank you. There's it right now. Okay, cool. See, it's going to be wrong if you don't type it correctly. All right, over here, I got -2, -2.5. So is +2, -0.5 a solution? No. Okay, so you just type it in and look at it. Now we're going to graph some ourselves. So we're reviewing how to graph lines. You've done this already. It's good old y equals mx plus b. Look at this first one. What is the slope? 2, and the y-intercept -1. So when you graph it, you're going to start at -1. You can think of that like moving the line down 1. It's a shift down 1. And then what do you do for a slope of 2? Can you use up 2 over 1? Okay. So from that point, you're going to go up 2 over 1. And how many points did I tell you to plot? All of them. Go as far as you can. And the reason why I coached you to do that is because of this exact reason right here. If your line wobbles and it's not perfect, you won't get your intersection correct. You're going to do your best. Did you graph that line? I'm ready to do the next one, but I don't want to leave you behind. Are you good?
Yeah.
I'm not talking to you. Did you graph? Okay. What's your slope for this one? A little tricky. -1. Good. That's a -1x, and then your y-intercept is 5. So you're going to start at 5, 0, 5. It's like an up 5. It went +5. And then how do you do a -1 slope? Yeah, down 1 over 1. So down 1 over 1, down 1 over 1. And you need to be really accurate or your intersection point will not be correct. I'll use another color. We'll see if it shows up here. What is our answer to the whole thing? 2, 3. You see how we did that there? That's the answer. That if you're like, that's it. Yep, that's it. This is a really easy unit. Are you with me back there? You understand what's going on? If I walk back there and look at your paper, you're gonna have all this written down. Nice job. All right, let's try another one. This has f of x and g of x. Does that mean anything different than y? No, it is very easy. Your slope for this one is 3/2. Y-intercept is 2. We're kind of just reviewing how to graph a line, really. So you're going to start at 2, which is right there, up 2. And then using words like up, down, left, right, what is the 3/2? What are your instructions? What does that tell you? Yep. So from that point, you're going to go up 3, over 2. Like if you can count to 2, you can do it, right? Now I'm going to go off the grid if I go any further. So I know my other point's going to be like down here-ish. I'm going to go down 3 and left 2. You just kind of want to let your instinct kick in. Like you can count. I believe in you. This usually goes well every year. Just got to stay quiet long enough to listen to me and actually do it. That's all. All right. And then the other line, your slope is -3 over 2. So be careful. That's different. And -4. Good job. So you're going to start at -4. It's like a down 4 shift. The whole line shifted down 4 is what you did. And then your -3 over 2 is telling you to go down 3 over 2. And if you go any further, you're going to be off the grid. So you want to put a few points go in the other direction. You would go up 3, left 2. Again, just kind of like let your pattern instinct kick in. You have instinct, just use it. And you can always, I'm not using Desmos right now, but you could always just type it in Desmos and click on the intersection. Yeah. Now, what is your answer? Yep, -2, -1. Good job. I'm just going to try a couple more. Sweet. I saw some of you finish that even before me, so nice job. All right, for this one, your slope is -1. What's your y-intercept? Good, it's 0, the origin, 0, 0. Now, before I even graph that, what's your slope for this line? -1, and your y-intercept is 3. Before we even do this, just foreshadowing. Look up here, now. Since they have the same slope, what are the lines going to look like? Well, not on top of each other, but what word do we have for that? Parallel. Good job. Okay, so that's what we're expecting it to look like. So this one, we're going to start at the origin. You kind of can't see that because it's right in the center, but point there, and then your -1 slope. So down 1 over 1. Again, if you can like count to 1, you can do it. I say that just to be silly and get everybody to do it. Like you count to 1, then you're fine. The other one's going to look the exact same, except it's instead of starting at the origin, you're going to start up 3, but it's going to, you know, run along parallel to the line we just graphed. So what does that mean? The answer to the whole thing, you can't forget to write an answer. It is no solution because they don't intersect anywhere. All right, so let's try this next one. Do you see any X's over here? No, it's just Y equals a number. This is your Hoy Vux. I'm just going to write the Hoy part of it because they're both Y equals. What does the rest of this stand for? The Y means it's Y equals, but what is the rest of this? Horizontal, 0 slope. So for both of these, your slope is 0. It's going to be flat. If they were vertical, what would the slope be? Close that computer. I'll write you pass when we're done with this. Close that computer. Undefined is the correct answer. All right. For this one, your y-intercept is 4. For this one, it's -1. So y equals 4. You're going to start at 4. And you can put in a lot of points if you want, but it's just going to be a flat line. So you can just draw a flat line going through 4. And then you're going to have another horizontal line, except going through -1. So it's going to look like this. Again, if they were x equals, you would end up with 2 vertical lines. That'd be the Vux part of your Hoy-Vux. But again, what's the whole answer to the special? Yeah, again, they don't intersect. So no solution. And if you were stuck on that, you would do what? Use Desmond's. Type it in, it'll show you the graph. All right, we're going to try one more and then have some follow-up questions here. All right, y equals 1/2 x minus 3. Slope is 1/2. Your y-intercept is -3. So how would I graph that? Where am I going to start? -3, good. So put a point right here. And then your slope is 1/2. So what is that telling you to do? Like, what are your instructions? Yep, up 1 over 2, up 1 over 2. Again, if you can count to 2, you can do it. Just keep on going. Now, what's wrong with the other? Well, not wrong, I guess I shouldn't say what's wrong with it, but what's not good about this? Yeah, it's like all jumbled up. That means we have some work to do to get y by itself. What would you start doing to shove everything to the other side? Good, -6. Subtract 6 to both sides. That would give you 2y equals x minus 6. X minus 6 is not 6x. I get that a lot. We're subtracting, not multiplying. So x minus 6 is just x minus 6. Can you write this down with me, please? All right, and then how do you get rid of the 2? Yep. Good. Divide everything by 2. Divide 2, divide 2, divide 2. So y equals, now this is really kind of tricky. Good. There's really a 1 in front of that x, so it's 1/2 x minus 3. What do you notice? Stop and notice something. It's the same thing. So if we graphed this line, it would be right on top of the other line. So we have 2 lines. They're just right on top of each other, which means they intersect literally everywhere. So it's infinite solutions. They intersect every place. What's that? Oh, thank you. There we go. Crisis averted. All right, a couple of little follow-up questions. Oh, I already asked you this. Can a system ever have 2 solutions? No, because a line doesn't bend. Lines are straight. So if they keep on going in the same direction forever, it's not going to bend back on itself. If you want to put a reason why, lines don't bend, be the reason. All right, and then this is kind of tricky, but I believe in you. Does this system have a solution? Why or why not? What do you think? Will there be a solution? Yes is the answer, because look, it's tilted. That's a good way of saying it. It's tilted. They're not parallel. Do you see how if this one continued, I mean, like we have this grid, but lines keep going. That's what the arrow means. And then if this one keeps going, they're eventually going to intersect over there. So you will get an answer unless they're parallel. And if you're on Desmos, sometimes you have to mess with the window a little bit, zoom in or zoom out, in order to find it.